Oh my gosh, we are finally learning about Note 6.9, the quadratic formula, and this is one of my favorite topics. I only wish I didn't have a cold and my singing voice was a little bit better, but I know you guys will love it anyways. Okay, we're gonna use the quadratic formula, which is this big ugly mess given to you on every reference sheet that you use on every exam in this course. But it's better if you sing it and know it. So that formula is going to help us find zeros of something that looks like a quadratic. If you notice, this quadratic is written in standard form, meaning x squared, x, and no x. So for exercise 1, here we go. We got a quadratic. First, you need to be able to identify, if you notice what's in this formula, is a bunch of A's and B's and C's. We need to know what A is, what B is, and what C is. So I'm going to put a 1 in front of my x squared and call that my A value. So A is a 1. The B is the number in front of the x, so that's the 8. They're just numbers. Numbers. No letters, no x's, just numbers. And then the 3 is my C. It's also the constant. Now I'm going to carefully substitute these values into the quadratic formula. So I'm going to write the formula down. X equals negative b plus or minus the square root of b squared minus, oh, there's my stupid cough, b squared minus 4ac all over 2a. Just to make you remember that, I'm going to actually sing it for you, and I'm sorry, I have a terrible singing voice. This is to the tune of I love you, you love me. It's a Barney song. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so now I'm going to substitute these values in. X equals, the reason I say x equals is because we are solving for x. When we get answers out of this mess, they will be x values. Negative b also means change the sign on b. So if b is 8, negative b is negative 8. Negative 8 plus or minus the square root of b squared. Oftentimes when I find b, I immediately write down b squared, which would be 64. 8 times 8. So 64 minus 4 times a, which is 1. Make your square root longer. Times c, which is 3. I'm just taking those numbers and plugging them in. Over 2 times 1. Now I'm going to do a little bit of math. I always recommend you do what's under the radical first and leave the other junk alone. So negative 8 plus or minus all over 2. 2 times 1 is 2. Underneath the square root, you could go to your calculator and you could hit 64 minus 4 times 1 times 3. That's what I recommend you do. Control, add a page, add a calculator. 64 minus 4 times 1 times, I forgot the last number because I have a terrible memory, 3. 4 times 1 times 3. Enter. 52. 64 minus 4 times 1 times 3 is 52. Okay, did I do that? 64 minus 4 times 1 times 3. I think it's right. All right, so now I have x equals negative 8 plus or minus the square root of 52 all over 2. But the next thing I do after I get that number is I try to simplify my radical. What does 52 have factors of? Let's see. If we go to my calculator, I could take 52 and start dividing it to look for a perfect square. Divide it by 2. Nope, 26 is not a perfect square. 52 divided by 3. Nope, that didn't do anything. 52 divided by 4. 13. Ooh, that's a red flag. 13 is not a perfect square, but 4 is, and I don't think 13 is going to break down any further. So that's what I'm going to use, 4 and 13. There's my perfect square first. Square root of 4 is 2. Now I have x equals, extend my page a little bit here, negative 8 plus or minus 2 rad 13 all over 2. So I simplified my radical, and now I'm going to simplify my fractions. I bet you don't see these fractions yet. Negative 8 over 2 plus or minus 2 rad 13 over 2. I call this loving the problem because I'm taking the two pieces centered around the plus or minus and I'm separating them, both dividing by 2. Reducing your fractions, negative 8 divided by 2 is negative 4, and 2 divided by 2 is a 1, so that's just radical 13. So my two values, this should look familiar, we've done enough problems that look like this, negative 4 plus rad 13, and negative 4 minus rad 13. We've had answers that look like that before, just yesterday when we were completing the square. Let's try another one. Consider the quadratic equation. Find the solutions to this by factoring. All right, so they don't want us to use this lovely formula. We're not going to even have to sing a song. We're just going to say 2x squared minus 9x plus 4 equals 0. Well, this is one of those awkward ones to factor because it has a 2 in front, but you can always turn roots into factors. So I'm going to go and find my roots on my graph. So looking back here, I think on a previous page, I already graphed this thing. There it is. And I already marked a 0 at 4, 0. So just knowing one nice root is at 4, I can change a factor to be x minus 4. So in order to get a 2x squared, this must be a 2x. And this must be a minus 1 for that to be a positive 4. If you had looked at the other root, it was actually at 1/2, I believe. Let me just look back. Yep, 1/2 was my other root. So there's where my other factor comes from. But anyways, set your factors equal to 0. X minus 4 equals 0. Add the 4. X equals 4. 2x minus 1 equals 0. Add 1. Remember, after you factor, you set your factors equal to 0 to solve for x. So I got 2x equals 1. Divide by 2. X equals 1/2. Yep, those were the roots I saw on the graph. Now I'm going to do the same question using the quadratic formula and get some good answers out of this. So I have to identify my A, my B, and my C. Looking back up here, A is 2, B is the negative 9, C is 4. It's already in standard form, so you can see those very easily. Again, I like to write down what B squared is. Negative 9 times negative 9 is 81. Squaring a number always makes it positive. Negative times a negative is a positive. We're using the quadratic formula. Sing it. X equals negative B plus or minus square root of B squared minus 4 times A times C all over 2A. And then plug in. You're substituting. Negative B means change the sign on B. If it was negative 9, it'll be positive 9. That's negative, negative 9. Positive 9. Plus or minus the square root of B squared. I already did that. It's 81. Minus 4 times 2 times C, which is 4. All over 2 times A, and A is 2. Okay, so if you remember what I told you on the last problem, you should be calculating what's under the radical now. 81 minus 4 times 2 times 4. Add a page. Oh, I didn't mean to do that. Escape, escape, escape. Control. Add a page. Let's add a calculator. And we want to do, I'll see, I already forgot the math again. 81 minus 4 times 2 times 4. 81 minus 4 times 2 times 4. Enter. 49. Ooh, that's a nice perfect square. That just got me excited. You'll see why in a second. 9 plus or minus the square root of 49 is the number under the radical. All over 4 because 2 times 2 is 4. The reason I got excited is the square root of 49 is 7. That's a nice number. I can actually calculate. 9 plus or minus 7 all over 4 is much nicer than a radical 52 in the last example. So I don't just simplify a radical this time. I'm just going to do 9 plus 7 and divide by 4, 9 minus 7 and divide by 4. This is 16 over 4, which is 4, and this is 2 over 4, and that's a half. You just do the math. So sometimes you get nice answers and sometimes you get fractional ones. Oh, wait a minute. Yeah, 4 and 1/2. Those are the same answers I got by factoring. Let's turn the page. Exercise 3, you're going to find the roots using your technology and round to the nearest tenth. Wait a minute, what are we finding the roots of? Okay, so I took x squared plus 6x minus 9 to my graphing calculator, and I graphed it. And if I hit menu right now, not menu, I meant to hit trace. Let's see. Yeah, menu. Oh my gosh, I'm losing my mind. Trace, graph trace. And I try to find these zeros using technology. So I'm going to start on the left. Keep hitting this left arrow a few times without messing up my calculator. And eventually, I'm at negative 0.36. I'm going to hit a 0. That's not a very nice number. Negative 7.24, and that negative 2e, negative 12, that means 0, by the way. So I got negative 7, oh my gosh, what was that again? 0.24. I think that might even have been some sort of rounded number that my calculator gave me. I don't reckon, that's not a 0.5, that's not a 0.3 repeating, that's not a 0.66666. I don't recognize that. So it can't be factored if it's not a nice number. I can't turn that into a nice x plus something. Okay? So if that's not a nice number, let's look at the other one real quick. I don't know how quick it'll be, but I'm going to try to hit trace. Go to the right here. Come on, move around, shake it up. Let's go, let's go. Oh my gosh, this is slower than slow. Here we go. Maybe I should sing the quadratic formula while I'm doing this. X equals negative b plus or minus the square root of b squared. Oh, here it is. 1.24. I don't recognize that one either. X equals 1.24. That's not a decimal, I know. It's probably something rounded. Don't know how to make a factor out of that. Can't just put the decimal right there. That's highly illegal. So you can't factor it. You need to use an alternate method. So here it is again. Same function from up here in exercise 3. I didn't do any explaining here. Explain needs words. I better say, since the roots are not nice numbers, since the roots are, I'm going to say irrational, because I have a feeling these were a dot, dot, dot number that the calculator rounded. So if they're irrational, you can't make nice factors. You can't make factors. All right, so let's do this. Simplest radical form, quadratic formula. All right, A is 1, B is 6, and C is not just 9, it's negative 9. Again, B squared, 36. X equals negative B plus or minus square root of B squared minus 4 times A times C all over 2 times A. X equals negative 6 plus or minus the square root of, B was 6, right? B squared, which is 36, minus 4 times A times C. A is 1. C is negative 9 all over 2 times 1. So I got negative 6 plus or minus the square root of something all over 2. You should be worrying about what's under that radical. 36 minus 4 times 1 times negative 9. Control, add a page, calculator. 36 minus 4 times 1 times negative 9 equals 72. 72. 36 minus 4 times 1 times negative 9. 36 minus 4 times 1. Yep, I was right. Okay, so that's a 72. That needs to be simplified. 72, if I started dividing by 2, I'd get a 36 right away. And 36 is a perfect square. That's not too bad unless you're really bad at dividing. So 72 square root is now 6 rad 2 over 2. And if you remember, after we simplify the radical, we simplify the fractions next. And we're looking for simplest radical form. I'm going to take this up to here so I have more space. Negative 6 divides by the 2 on the denominator. I'm loving the problem right now. Plus or minus is in the middle. 6 rad 2 over 2. Simplify your fractions. This is simply a negative 3 plus or minus 6 over 2 is a 3 with a radical 2. You cannot divide what's under a radical with a number that's not under a radical. But 6 divided by 2 is a 3 with a rad 2 next to it right there. So that's technically my answer. I could write it as 2 separate things if I wanted to. All right, oops, do you want to say, ooh, cancel that, don't know why that happened. Exercise 5, find the solutions, quadratic formula again. Nearest hundredth tells me I'm going to hit some calculator buttons. So when I see that, I actually get excited because I can use my calculator relatively quickly here. A is 3, B is 4, C is negative 1. B squared is 16. X equals negative 4 plus or minus the square root of 16 minus 4 times 3 times negative 1 all over 2 times A was 3. Okay, so if I'm going to be able to use my calculator, why not use it right here and get my answers to the nearest hundredth? So I'm going to go to my calculator and I'm going to type that whole mess in. Control, divide, it's a big, ugly fraction. It's negative 4 plus, I'm going to do the plus first. Negative 4 plus, so negative 4 plus the square root of 16 minus 4 times 3 times negative 1. And on the bottom of the fraction, so down there in that box, is a 2 times 3. I'm just going to put a 6. And I'm rounding this to the nearest hundredth. So my decimal was 0.2152. 0.2152. This is the hundredths place. The 5 makes it go up. So it's approximately 0.22. And I got to find my other one. So go back to your calculator. If you highlight the mess that you typed in and hit enter, you can tab back or backspace back if your calculator cooperates and get rid of the plus and change it to a minus and hit enter. Negative 1.548, negative 1.548 dot dot dot. The hundredth place is going to become a 5, negative 1.55. So if it says nearest something and you can use your calculator, you don't need to do all the fancy simplifying of radicals. All right, exercise 16, if you're going to stick with me and listen to this one, this is a projectile's formula. This is its height, depending on its time. So, using your calculator, you're going to sketch a graph. I'm going to take a break and do that and come right back. All right, so let me try to tell you what I did here real quick. I took this equation, instead of t's, I graphed it using x's. I used trace. First of all, I adjusted my window to 70 and 3 and 0 and 0 down here. And I used trace to find some key points to plot this graph. I also looked at a table and found some values to help plot my graph. What I found was that the root is not at a nice number. It's between 2.7 or between 2 and 3. So then it said to solve it algebraically. Real quick, I'll show you the graph. Control backup page. There it is. So I played around using graph and trace, and there's the 0, 2.66. So I rounded it to the nearest tenth, but it did say solve it algebraically, So I'm using the quadratic formula. Again, I'm solving for t because t is acting like x, so I wrote t equals. T equals. This is just a, b, and c plugged into the quadratic formula, and I took this mess to my calculator, which I'll show you real quick. And when I look at my next page over, so there's my calculator. This one turned out negative. I didn't like that answer because time can't be negative. This one turned out positive, and that's actually 2.7. So I took it to my calculator with a big fraction and calculated 2.7.